My name is Nikhil and our team project is titled as the Library Management System. But before we dive into it, we need to understand the big picture and the principles regarding the database management system in order to truly understand the technical concepts such as the ER diagram and the relational schema. So we'll take a first look at why we actually require a database in the first place. Suppose you have an online store where you sell different products. Now a customer named Alice wants to buy a product. So when she makes the purchase, we want to record all of the information of her in a spreadsheet program. Later on, the same customer named Alice buys a different product next time and her address gets changed as well. So you record that information as well. So the customers keep on buying the products on your website and you keep on recording all of the information into your spreadsheet program. But the problem arises when Alice calls for one of her orders, and when you pull the information, you get two different addresses and two different products, and you're not even sure whether you're talking to the correct customer or not. This is because each and every information regarding the customer is just stored in a single spreadsheet program. The information is disorganized and there is redundancy of the data. This might lead to a messy situation. The shipments can get sent to the wrong address, customers can get mixed up, and the wrong products might get sent to the wrong people. So how can you solve this problem? So instead of using a single spreadsheet program for storing the information regarding the customers, you can divide the information, separate the information into three different tables. For that, you can have a customer table in which you store the details regarding the customer. Then the second will be the product table in which you store the details regarding the products. And you will have the order table when you actually make the purchases. That information will be stored in the order table. Now, for example, a customer named John tries to buy a product. So when he makes the purchase, he enters his name and address. So that information gets stored into the customer table and we assign a customer ID to that particular customer. In the product table, we have different products which each having a different product ID. So when John actually makes the purchase, we store all of that information in the order table. We pull the customer ID and the product ID. So we now know which customer bought which product. This is the most efficient way of pulling the information because the data is now more organized. So even if now the customer's address gets changed, it will only affect the customer's table and not the product or the order table. Even though we have three different tables, these three tables are connected to each other. And this connection is what makes it a database. Hence, we can define a database as a collection of information which can be stored, managed, retrieved, and updated. Now let's take a look at how a database is useful in a library management system. Suppose you want to find information regarding a particular paper or a magazine. So information which can be accurate, reliable, and authoritative. You can find all the answers in a library database. A library database is an index collection of magazines, journals, papers, and abstracts which have been checked for accuracy and reliability. All the sources in the database are known to come from the known sources. So what is the difference between using a library database instead of finding that information from the internet? The biggest advantage of using a database is that the information in the database is copyrighted. Libraries actually pay to have access to this information. If you want to find out something from the internet, you might have to scan through billions of websites and links in order to find something you want. Most of the links can be outdated. As anyone can publish on the internet, most of the things can be unreliable, unsafe, and inaccurate. But if you have access to the information through a database, it can provide us with the information or data which is safe, accurate, reliable, and copyrighted. Hence, a database is really useful in a library management system. But the problem with the database is that it does not provide a reliable way of visualizing the database structure. For that, in order to solve this problem, we need to use an entity relationship diagram. So now let's take a look at what is ER diagram. Entity relationship diagram is a visual way of representing a database structure. For the ER diagram, we need to know three things. The first thing is the entity, which we consider as an object that can be a person, place, or thing, and that's something which we can keep track of in a database. In our example, we have 6 strong entities such as customer, employee, library, book, publisher, and payment. We also have something which you call it as a weak entity. In our example, membership is a weak entity. But what is exactly a weak entity? It is an entity that cannot be uniquely identified by its attributes alone. Therefore, it also must use a foreign key in conjunction with its attributes to create a primary key. That means it cannot stand on its own and is dependent on the customer entity. The next thing comes is the attributes. The attributes provide more information about a particular entity. The attributes are represented using an eclipse. So in our case, we have a customer entity which has attributes such as date of birth, contact, customer ID, and age, which gives us the additional information about a particular customer. But we actually have many different types of attributes. The first one is a single value attribute. So in the customer entity, we have the customer ID as a single value attribute because we use it as a unique identifier. So that means this attribute consists of a single value. The next type of attribute is the derived attribute. The derived attribute is an attribute whose value is derived from the other attributes. It is represented using a dashed eclipse. So in our example, the age can be considered as a derived attribute because if we know a particular customer's date of birth, we can easily calculate its age. The next type of attribute is the multi-value attribute. A multi-value attribute comprises of two or more values. In our example, a contact is considered to be a multi-value attribute because a customer can have more than one contact. The last type of attribute is called as the composite attribute. An attribute is considered to be composite if it consists of two or more attributes. In our case, the section is considered to be a composite attribute because it consists of two or more attributes such as the novels, magazines, papers, and comics. Now, having talked about entities and attributes, we need to talk about what relationships are. The relationships describes how these entities are connected to each other. We do this by drawing a line between the entities. These lines prove that there is some sort of interaction between the entities. You might also see some notation beside these lines. These are called as cardinalities. Cardinalities describe the relationship in terms of numerical context such as the minimum and maximum. So we have different types of cardinalities such as one-to-one, one-to-many, many-to-many, and many-to-one. So let's talk about the relationship and cardinalities for the customer and the book entity. We have to think about this in a logical way. What is the minimum number of books a customer can rent, which is obviously 0? And what is the maximum number of books a customer may rent, which is infinite? That's why we use the notation n for describing the many relationship part. Now we have to do the same thing on the customer side. What is the minimum number of customers a book may have? And what is the maximum number of customers a book may have? Which is obviously the answer is 1. Because one specific book can only have one customer. Imagine the confusion that may arise if one book is rented by many customers. So obviously we use the notation 1 to describe the relationship between a customer and a book as 1 to many, which means that one customer can rent n number of books. So having learned about what entities, attributes, and relationships are, we now move on to our last topic, which is the relational schema. The relational schema helps us to organize and understand the structure of a database. This is particularly useful when we are actually designing a database or modifying the existing database in order to support more functionality. So we actually have two types of relational database schema. The first is the logical schema and the second in the physical schema. Here we have depicted the logical schema, which shows us the structure of the database, such as the tables like books, libraries, or employees. Then we have columns, so each table has columns such as a book table has columns like ISBN number, title, author, price, and so on. And obviously the relationships between each and every table, which is depicted by using an arrow. The one thing we need to know is that the structure of the relational schema will inevitably change over time as data needs change. So it's important to document the changes to your relational database schema as it was to document the original design. Otherwise, it will become increasingly difficult to update or integrate database. Hence, I'm hopeful you got to learn a lot from this video, such as what database is, how is it useful in library management system, what is ER diagram, and what relational schema is all about. Thank you for watching.